Hello, ladies and gentlemen. What I want to talk to you briefly about is why finding the polarity of bonds and then why finding the polarity of the molecule can be really beneficial for us. So in the last video I ended talking about water. And so what we did is we found the electronegativities of the hydrogen and the oxygens, and oxygen was 3.44, hydrogen was 2.2, so we subtracted those, and what we found was that the difference in electronegativities was 1.24. So what that meant is that these bonds in water, the oxygen and hydrogen bonds, were polar. So what that meant is that electrons were being pulled from the hydrogens towards the oxygen, and what that did is that created a partial negative charge on the oxygen and partial positive charges on the hydrogens. Okay, so I went over that kind of in the last video. But what I want to show you is that when we do this with molecules, you might ask, well, what does it mean for a molecule to be polar? Why is that important? And so what that means is that these molecules kind of act slightly like magnets. Okay, so magnets have a north and a south pole. They have a positive and a negative pole. We just call them north and south. So molecules that are polar now have these positive and negative poles. So what they'll do is they'll actually act like magnets. And you'll be like, well, how can we test that? So I want to show you guys something that's pretty cool. So here's what I have. Inside of this burette right here, I have some water, H2O. Then what I'm going to do is I've got a red balloon right here. And what I'm going to do is I'm going to rub it on my head. So while I'm rubbing this on my head, think about what that's doing. Okay, you guys have probably rubbed a balloon on your hair before. And what that does is that creates a buildup of static electricity. So I'm going to show you what happens when this water molecule comes into contact with my balloon. So, how do we explain what you just saw? What was happening that caused that water to be attracted and be bent by the balloon? Well, here's what was happening. You have your balloon, okay? Now, when I rub a balloon on my hair, what happens? You get a buildup of charge. Now, that charge that builds up on the side of the balloon is a negative charge. Okay, so this will represent my balloon. Then I had my burette, okay? And my burette was dripping down water. Now, what you saw happen was you saw, as that water dripped down, it bent towards the balloon. Now, why did that? Why did it do that? So, here's what was going on. Your water molecules, again, they're polar. They have positive and negative sides. So, what was happening is as those water molecules dripped down, okay, I had hydrogens, and what charge were they? Well, they were positive, right? So they have this partial positive charge on them. My oxygens have a partial negative charge. Well, all of these partial positive charges were gradually turning and going towards the balloon. So what happened is these positive charges here attract, right? These positive charges got pulled towards my balloon. And so as they fell down close to the balloon, they got pulled to the side. Now, this happens in water like all the time, except instead of water being attracted to a balloon, they're attracted to each other. So here's what happens. I'll use my kind of diagram right here from previously. Okay, if I've got water, okay, it's polar. It's got a negative side and a positive side. Well, what would happen if I had another water molecule get close to this water molecule? Well, this side of the water molecule is partially negative, right? And these sides are partially positive. Notice how I now have a positive and a negative really close to each other. There's going to be an attraction there. What that means is every water molecule is almost like a tiny little magnet. So when a bunch of water molecules get close together, okay, they start to attract to each other. They kind of stick together. And so when they start to stick together, what that does is it kind of changes their properties a little bit. when you have polar substances, they typically have higher melting points, higher boiling points, which is why water, actually for its size, for its molar mass, which we'll learn how to calculate later on this year, it has a really high melting point. Other molecules that are around the same weight as water are gases at room temperature, not liquids. Now the reason why is because of these, what's called these polar bonds. These polar bonds help them to stick together and stay in the liquid phase. So determining polarity really helps us tell a lot of things about chemistry and how things interact with each other and why they interact with each other in the ways that they do. So this was just something really interesting that I wanted to show you. So thanks for watching.